Trigonometry Unit Section 2, choosing the correct trigonometric formula to solve a problem. If you decide that using trig is a good idea to solve a problem, one concern might be remembering the three trig ratios. And to help us, we will look at this mnemonic. So, ka, toa. The first letter stands for the three trig functions, S for sine, C for cosine, T for tangent. The next two letters in each word represent the sides used for that function. So the OH is the ratio for the sine function. The AH, which follows C for cosine, is the ratio for cosine, adjacent over hypotenuse. And the OA, opposite over adjacent, is the ratio for the tangent. So if we can recall SOHCAHTOA, that will give us the three trigonometric ratios that we need to solve a right triangle. Let's look at it in practice. Given this triangle, we need to determine the reference angle. Once we've established the reference angle by choosing one of the acute angles, we will label the triangle opposite side, hypotenuse, which is opposite the right, the longest side, and the third side adjacent. We will look at our memory device and choose the correct ratio that will help us solve for the missing value, which in this problem is the angle, based on what we know. We know opposite and adjacent, so we look through our list. This one, first one, is involving hypotenuse. We don't know anything about it right now and aren't asked what it is, so that doesn't work. Neither does this one, but it's the third option that's going to do the trick. TOA stands for tangent of the acute angle is equal to O for opposite over A adjacent. We would plug in those values, simplify using our calculators. We would replace the fraction with a decimal equivalency. This is kind of the Jeopardy looking where we have the answer, what's the question, where we need to do inverse tangent to arrive at the value for the measurement of angle A. Here's another example. Establish your acute angle as your reference. From that, label the sides of your right triangle. Identify what's given to determine which of the three ratios that you're going to use. And to help us remember what those ratios are, we have this memory device, SOHCAHTOA. We're looking for the opposite side, and we're given the hypotenuse. And if you look here, the letters following S are OH for opposite and hypotenuse, so we'll use the sine ratio. Replacing the unknowns with the given particulars for this problem, sine of 32 degrees, the angle measurement is equal to the opposite we don't know over the hypotenuse, which is given as 12. Solving this, when our variable is in the numerator, we multiply both sides by 12. Simplifying this expression gives us the length that we're looking for. Here, we're given another right triangle, same procedure. Identify your reference angle. From that, you can label your sides of your right triangle. What are they giving you and what are they looking for? They're looking for the hypotenuse and they give you adjacent. That relationship is the middle one. C for cosine is defined by adjacent over hypotenuse. That will be the ratio that will solve the problem. Replace what is given. Cosine of the angle we know is equal to the adjacent we also know over the unknown we don't. And if you recall, when the variable's in the denominator, this is where we can, through correct procedures, and a shortcut is to just switch those two values. The variable goes to the left and the trig function goes in the denominator. Using your calculator, starting with the numerator, 9.5 divided by cosine of 29 gives us the solution we're looking for. Here's another series of examples. Can you solve this problem? First, what we see is a right triangle with two sides known, so we'll use trig to calculate the angle measurement. First step, identify your reference angle, which is angle T. That's what we're looking for, the unknown, from the reference angle. Second thing we want to do is label the sides. Third recommendation is discard what we don't need, and in this case we don't know anything about the hypotenuse, aren't looking for the value of the hypotenuse right now anyway, so that can be discarded. What's left with is the opposite and adjacent, so we'll go to our memory device to pick the trig ratio that involves the ratio adjacent and opposite, which is tangent. Replacing what we know for those values, we'll set up our formula. We don't know the angle, but we do know opposite and adjacent. We can replace that fraction with a decimal. And because we have our answer and we're looking for where it originally started, we'll do our inverse tangent, and hopefully you will agree that the answer is 53.5 degrees. In this next example, same thing. In this one, we're given a side and an angle. We can use trigonometry to solve for the missing side. Same procedure, setting up our steps. First, we want to identify the reference angle. Once we've established that, we can label the sides of the triangle. Opposite first, hypotenuse, and third side is adjacent. Discard any unneeded information. We're looking for the opposite side. That's where the variable is. No indication of interest for adjacent, so we'll discard that. Next, based on what we're given, hypotenuse and opposite, we'll choose the trig ratio involving those values, which is the sine. Replace those values with the specifics from this problem. We do know the angle measurement, so we'll say sine of 40 degrees is equal to the opposite, that's our variable, over the denominator. In this example, our unknown is the numerator. This looks like an algebra problem where to undo division, we'll multiply both sides by 68. And hopefully you find, if you simplify this, a value of 43.7. In this next example, we're going to identify the reference angle first, just like in the previous ones. Once that's established, we can label the sides. Opposite the reference angle, longest side hypotenuse, third side adjacent. Discard unneeded information. Don't know anything about opposite side and aren't looking for that, so discard it. We're dealing with an adjacent and hypotenuse. From the memory device, which of the three trig ratios involves adjacent and hypotenuse? There it is. Cosine is A for adjacent, H for hypotenuse. Replace the unknowns in that ratio with the values from the problem. We do know the angle measurement, so we will replace A with 25 degrees. Adjacent in the numerator is 21, and the denominator is our missing value. When we have a ratio with the variable in the denominator, we have our shortcut that we can switch these two values around, putting the x equal to 21 divided by cosine of 25, and when you simplify that calculation, the answer is 23.2 feet. Reviewing, here we have another triangle. Same thing. Start with identifying your reference angle. That's the base and the hook that determines how you will label the sides of the triangle. Opposite side, hypotenuse side, and the third side being the adjacent. Discard unnecessary information, so hypotenuse is gone. We're looking for the measure of angle T, and we're given an adjacent and an opposite length. That entails using the tangent, TOA. Tangent of an angle is equal to the opposite over the adjacent. Replacing those variables, we'll set up our formula. Do the indicated division, replacing the fraction with a decimal. And then, because we have our answer, we will strike the keys that take the inverse tangent of that ratio to give us the angle measurement of 53.5 degrees. So here are other examples. Once we have a reference, we label our sides. We're dealing with opposite over hypotenuse, which is the sine function, OH. Sine of the angle 64 is equal to the opposite. We don't know. We'll put an X there over the hypotenuse. We want to solve for X. To get rid of a division, we will multiply both sides by 8.5. Simplifying, our final answer for the missing side is 7.6. In this last example, determine your reference angle. From the reference angle, we can label the sides of this right triangle. We discard the unnecessary, which is the adjacent side. We're looking for X in this problem, which is the hypotenuse. Which trig ratio deals with opposite and hypotenuse? So, and I'm going to stop there. I don't need the so katoa, the remainder. So sine of the angle opposite over hypotenuse, replacing those values. And here we have the variable in the denominator. When that's the case, we will switch these two values around, leaving us with the numerator 68 divided by the sine of 50 degrees, final answer 88.8. For additional practice, look at the problems on practice set 16.